Okay. All right, good evening, everyone. We'll be starting shortly. We are now waiting for people to file in, and yeah, it'll be a great night. We're looking forward to it. Okay, I think we'll begin. I think some people are still filing in, but we could probably get started. Thank you for joining us tonight for Soils as an Essential Research, and Practice. This is the first of a two-night event for ASLA-New York's 4 CEUs and a beer. Our part 2 will be happening on March 30th, and you could sign up for that event on our website. My name is Renee Dillon. I'm the co-chair of the Programs Committee of ASLA-New York, and I will be hosting tonight for our talk with Tim Craul, president of Craul Land Scientists, Inc., followed by Chris Siciliano, sales director of Stancil's Soil and Gravel, and followed by Laura Solano, a principal at Michael Van Valkenburg Associates. It's going to be a great night tonight, and we'd like to thank a couple of sponsors. If I can get the slide to go. Here we go. Our platinum sponsor tonight is Bartlett, and thank you to them. I'll leave this up. Bartlett Tree Experts, I'm sorry. And we'd also like to thank Deeproot. They have helped us a lot with this event, and we really appreciate all of their help. Here's a project that they've worked on. All right, and with that, if you could please put any questions in the question and answer box and not the chat, it'll make it much easier for us to ask your questions later. So now I will stop the screen share, and Tim, you can take it away.
Hi, all. Getting squared away here. I hope everybody's having a good evening. Today we're going to discuss Tools for your toolbox. I'm of the purview of that you never throw away a tool. You could always find something to use it. But you want to make sure that having a little glitch here already. How about that? We have the tools for the toolbox. We're going to make sure that we don't use a hammer, like a wrench for a hammer. It might work, but it may not do so well. We're going to touch base a little bit, kind of an introduction to soils. And we're going to deal with soils as a plant medium so that the productivity is based on limiting factors of the soil. Some of these factors, we cannot be really manipulated too well. There's others that we can, such as nutrients, organic matter, water, and other such things that we can either add to it, amend, or design into our specific soils. The other item we may have too is that most times environmental factors may or may not be able to be changed. Now we can adjust them here and there, but they have a tendency to be we got to live with it. It's like can't really mess with Mother Nature very much. So basically, if you're looking at the standard soils requirements for decent plant growth, you need to have some oxygen. You need to have a decent amount of pore space. Your bulk density over here needs to be under these levels over here for clays and a little bit higher for sands. Generally, that works out to be about 1.5 grams per cubic centimeters for clays and about 1.75 grams per cubic centimeters for sands. That changes also with the particle size distribution of those sands as well. So if you can get some penetration resistance and actually get some stuff to move it, it kind of equates to roots elongating through the soil. Then we have our soil pH, water content, cation exchange capacity, soil organic matter content in the surface. And I like to use soil organic matter content because that's typically the stuff that's derived from detritus and is gobbled up by our soil biology. And then last but not least is rock fragment content. There's been several studies done in Israel where once we get over 20% rock fragment contents, we have a significant decrease in productivity of their fruit trees, as well as some other trees that they were looking at as well. So generally speaking, that's what we need to do. So if we deal with our basic soils, there's multiple ways of handling soils, either using in situ soils or design soils. But we have this soil density limitations that are sort of kind of cut in stone, so to speak. So therefore, if you're a sand or a very coarse sand or loamy sands, your bulk density that really restricts root growth is about 1.8 grams per cubic centimeter, which works out to be about 112 pounds per cubic foot. Then if you get down into this, typically the stuff that we would like to use, loams, silt loams, the good stuff, the stuff that most highly productivity agricultural soils are at, their bulk densities are actually quite a bit lower before they start reducing root evolve. And that's typically about 1.7, but you will see some restricted root growth at about 1.6. And then if you're down into the sandy clays, silty clays, the fine sandy loams, that's much, much lower. So if you take a look at it this way, typically we have an idealized bulk density of any soil texture where you have about 25% water, 25% air, about 5% organic matter, and the rest is mineral. That equates to basically a bulk density of about 1.33 grams per cubic centimeter. Well, if you get a well-graded soil at peak bulk density, at optimum moisture content, your bulk density kicks up to about 1.96 grams per cubic centimeter, or over 122 pounds per cubic foot dry. Roots cannot go through this type material. It's just too dense. So if you have a poorly graded soil at peak density, what happens is it is sort of comes self-supporting, and even though you can really compact it, it still remains an awful lot of air space left in it. So your maximum bulk density is about 1.7 or about 106 pounds per cubic foot. This all comes down to the particle size distribution chart, because unlike soil texture, which is just a reading of the fine earth fraction of the soils, the sand, silt, and clay, it does not include anything larger than 2 millimeter, and it contains everything less than 2 millimeter. So that if we take a look at a particle size distribution chart, we need to look at the whole soil to be able to handle it. That includes gravels as well. So if you will look here, the first line we have across here, the closer we get to a 45-degree angle on this chart, the more susceptible this soil is to compaction. So what you would then do is we would try to go through a soil that has what we call poorly graded, and it looks along more like a sinus curve. And in that vein, you have the well-graded versus the poorly graded, leading to different results in dealing with compaction. The poorly graded will have a greater chance of resisting compaction, where the well-graded would not. Lo and behold, both these soils that you see on these curves are rated as a sandy loam. So if you look at this, they're both sandy loams, but they react differently to pressure. So if you look at it this way, of a standard packing model, your uniformly apported graded soils are basically the number of contact points that you get between your different particles. The higher the contact points, the more well-graded the soil becomes, and the more easily it gets compacted, just because you can fill in the little bits. Therefore, not all soil textures are created equally. If you take a look at this, this is kind of to show what actually happens when we apply forces to soil. The first type of compaction is typically done where 90% of most compaction is done during construction processes, and this is a direct or a static application of force, where the other force you can also get is a vibratory force, where just vibrations are running through the soil system, causing the macropores to collapse. This is why a lot of steamrollers and sheep's foot have a vibratory application to their equipment. So if you look at this, here comes our static, and there goes our vibratory. So if we hit it again, there's our static, there's our vibration, and if you look closely at the pores that had the water left in them did not compress, because water is incompressible, but the macropores that connected all these smaller pores are now collapsed. So now we do not have a continuous drainage system within this soil. Here's actually a CT scan of what I just talked about. So if you cut down to the bottom part of these things, Jim Urban, who's later on next week, he found that basically 1,200 cubic feet is optimal for individual tree rooting volumes, according to some studies that he did. He found that anywhere between 600 and 1,200 cubic feet rooting volume is typical for surviving urban trees. Of course, then the differences then become the tree species, environment, soil properties. Now, in my design scopes, I typically use an absolute minimum of 600 per cubic foot of tree if you have a common rooting volume, i.e. a linear trench and you're sticking a bunch of trees in it, and 800 cubic feet for individual tree plantings. And this is the absolute minimum. I always ask for more. I pray, I beg, I get on my hands and knees and cry to the gods, give us, please, more rooting volume. So it's always better to have more rooting volume. So if you don't have the rooting volume, typically what happens is you get tree failure. About 90% of the time, most trees fail due to rooting volume restrictions. But every once in a while, you get an infrastructure failure. where the tree actually decides it doesn't like being confined and goes where it wants to. So in this particular case, we have structure failure. Okay, now with this, all this soils data basically in the back of your mind, the tools and proper use are basically try not to use a wrench as a hammer. It might work. You may hurt your fingers. So the tools, number one, be use of natural reference soils, i.e. soils that are in situ or something close by, you know, screen topsoil from a construction site across town, soils that are currently on site that have been stored to one side, basically natural soils. Then we have structurally supported sidewalks and drives, the Cornell structured soil, sand-based structured soil. Now, all these different things, types of things or tools for your toolbox to pull out of, but they need to be used in the proper way. They can't be just thrown at everything and hope it'll stick. So if we take a look at natural reference soils, the pros are they're usually close by. They typically have higher water and nutrient holding content, but then more compaction resistant or lightweight soils. They usually have an active structure development process with indigenous soil biology critters, so that they're already inoculated with the local good stuff. Generally, they have a higher productivity per unit unless they're degraded. The cons is they don't have the properties to resist the compaction or structure destruction when they're moved. In other words, they're also not homogeneous and they're easily degraded. They require a niring moisture content to work, and they're usually slow to dry out, which often delays installation. So how many people, I'm sure just about everyone on this call can raise their hands showing that the landscape was rushed to be put in and they're putting it in whether it's raining or not. If you have that problem, then natural reference soils with a finer texture is probably not the best way to go. They may not be suitable to withstand the interurban environment. Lots of people stomping across it, lots of events, heavy prescribed uses like concerts and stuff along those lines. So it would actually put a hurt on those type of soil properties, causing that compaction, leading to remediation more times than not. So if you take a look at the basic ideas that with soil biology and depth and prediction and how the soil naturally works, if you look at this is the way it works in nature. But if we move this soil or do stuff to this soil through construction, it no longer functions this way. So you look at something like this, and this is at Princeton. This is a reclaimed parking lot that they did. Notice they put nice, beautiful topsoil back on, but they left the gravel and some millings, and left here below that topsoil. They did not remove it. And then below that, in this 2BT1, was heavily compacted because they ran the steamroller over it so that they could actually support the pavement above it. But that was not mitigated. So you were left, if you take a look at the infiltration rate here on the far right, came down, looked pretty good through that AP, and then popped up where the gravels were. And then right about where this BT1 came in, it went to almost zero infiltration. So there was a lot of water ponding right here, and it wasn't getting into the subsoil. And this is what the soil should have looked like before they messed with it. Notice the nice uniform things. We had a little bump here into BT1 due to basically a plow layer and some other stuff that they had done to the site previously. But this is what it would look like naturally. Okay. Okay, if we take a look at structurally supported pavement, this is basically where we design some sort of mechanical means of supporting the pavement. This is either through silvicells, soil cells, or suspended pavements on some kind of cantilevered system, or piers with a matrix of stuff. The support of the pavement is separate from the planting soil structure. This basically allows that you can use a more delicate planting soil that can hold more nutrients and water, reducing your water needs and then increasing your productivity of your trees within that. It needs a less rooting volume per tree than a sand-based or fragmental systems because you are providing more water holding and more nutrient holding for those trees. However, that needs to be they need to be used in specific conditions, or else some other things start to happen. It's pretty expensive per square foot to actually do this kind of construction. Cell systems, they typically have the difficulty fitting around underground utilities if the underground utilities are kind of going kitty corner to the layout of the cells. The other thing that also happens too in a high vibratory environments, i.e. next to very heavily trafficked roads and streets where triaxles and heavy equipment are going, that vibration shoots out probably a good 100 feet from the side drive itself that we need to adjust for. With that high vibratory environment that causes shaking of the soil, and if you have a soil dealing strictly with structure, it's at optimum moisture content, and guess what happens to the macropores that are in there? They collapse, leading to subsidence and other issues that you have a gap between your support and your pavement, which may not be able to support anything that drives on it. This is actually a mechanical support system. This was used at Euclid Avenue in Cleveland. This was designed by Sisaki and Associates, a project I worked on. We put a sand-based soil in here because it was right along Euclid Avenue, a heavily trafficked area, with a tram that went down the middle of it. So therefore, we did use a sand-based type soil in here, but we did not have to compact this to 95% of standard Proctor. This was laid in about 90%, just to ensure that we filled all the spaces and we didn't get too much subsidence. I haven't been back to check it, but I believe there's probably some subsidence in here, but it probably is maybe less than an inch. Here's a silvicell suction. We're doing this down in Philadelphia. The silvicells are actually placed in over structure where the silvicells are going to be above a parking garage. So this cantilevered concrete system is going to be subjected to some vibrations. So we were considerably worried about a settlement of this material. So in this particular case, we're going with a soil here where it's resistant to compaction. So in that vein here, this is also being applied for that particular case. In some other cases where the area was well away from some vibratory effects, we could use something that was finer textured with less compaction applied to it. Okay, the Cornell structured soil can support the pavement and truck traffic over the networks of utilities, and it basically fits the opening. It's cheaper than supported pavement stiffness because we don't have to build stuff, we just fill a hole. Large amounts of gravants, and I have a typo mistake, they actually ensure high infiltration. The underground utilities are not an issue to work around because you can fill in around them. However, the rigid matrix does not allow structurally sound framework roots. The gravel used can also be detrimental to soil chemistry. So if you use, like, say, a limestone or some kind of gravel that has a high pH generally, that could increase the pH much more within the system itself, and we'd have to offset it. The other possibility is you could get a gravel in there that's actually expanding gravel. Once you add water to it, it has a tendency to lift. So you have to be careful on what gravel you use there. The addition of hydrogels can also lead to a portion of moisture retained and unavailable to plants. I've seen some newer hydrogels that have a tendency not to do that, but I'm not really sure which ones are where, and I'd be a little bit careful about putting too much hydrogel in a system. Last time is, according to the Cornell thing, you need to find a silty clay loam to use for the mix, and it's very difficult to find a good upland silty clay loam in a lot of places. So that may be detrimental. You may have to go with something coarser textured anyway. The main reason I was talking about is that the stone itself, if it falls into a cubic stone arrangement, you can actually get a straight line void so that roots can go straight line through it. But typically that doesn't usually happen. You usually get a tetrahedral packing, which then causes the root path to be undulating and not a straight line. So this is retaining to the framework roots itself. Now, framework roots, they actually develop their own cross sections to be able to structurally support the tree. And I believe Cora and they finally look at roots at this size where they become what I like to call slinky roots. For fine root hairs and small roots, as you've seen here, this system is not a detriment to that. But for a framework roots in close to the tree that have to be structurally sound to support the tree crown, you need to have a clear way of those roots to generate their structural soundness. And a rigid stone matrix doesn't apply that. And if I'm correct, I believe Cornell now states that you have to, this stuff is used out away from the main tree root, the tree trunk itself. I don't know what the definite, I have to look it up again, but that's the last I read. So basically the other item you have here is that you increase your bulk density by using the coarse fragment content, the gravel chart you see here up above. As you increase your rock content, the gravel on here on the bottom, you decrease, oops, hitting the wrong buttons here. Your saturated conductivity drops as well as your bulk density is increasing. And with that, you have a bit of a problem. The other thing is that down here, in a comparison between a CEU soil and a sand-based structured soil, the CEU soil, as you increase the density of the interstitial rock pore space and the silty clay loam, as that goes up, you decrease your plant available water. Now, I wouldn't really use these numbers too much because the Saxon and Rawls equations themselves were generated for fitting curves around data, and a majority of that data was in the center portion of the texture triangle. So therefore, as you get towards the outside edges of the texture triangle, the fitting equations that they use have a tendency to go kittywampus on us. So we need more data to kind of plug in there to ensure that that's actually happening or not. But at least it makes logical sense. So the sand-based structured soils, the pros, it can support the pavement just like the Cornell structured soil, fits the opening. It's cheaper than supported pavement systems and the Cornell system because it's just, we don't have to mix up anything special. We just find some good sand someplace, although that sand needs to be relatively good. The materials are more readily available and it resists the vibratory compaction from adjacent traffic. Can also act as a green infrastructure system. If we have something that infiltrates an awful lot of water, we can run an awful lot of water through it, which would then filter that water. By the time it gets to the bottom, then we can take that water coming off the bottom and say that, okay, we filtered it and it has helped with the quality of that water going out. The cons is the low moisture and nutrient holding capacity. These sand-based structural soils are droughty. They also have low nutrient holding capacity. but we can tweak this with organic matter content, addition of biochar, a few other things. The particle size distribution of sand required to obtain the compaction resistance is fairly tight, and not all sands work well here. If we get a sand that has a high level amount of calcium carbonate in it, it will tend to gel and actually cement the sand particles together, which is just as might as well be almost concrete anyway. The freshly mined natural sand can also cause the cementing, like I mentioned, but the thing is it has a propensity to have a high pH content. And until we get some nice rainfall events running through the system, that pH is going to stay up high. Now, with the pavement system around it, if we have concrete, there's a problem of runoff from the concrete that is very high in pH, and we can get soils underneath that concrete sidewalks to be fairly high. And that is true with all systems here. The thing with the sand-based structure soils is since it is coarser material, it has a tendency to flush more readily than a soil that is using a finer texture. Good medium sand is also difficult to find in areas that are supplying for fracking. Try to find decent sand in Chicago. Most of that stuff has been shipped through out west to South Dakota for fracking. It's hard to find decent, good medium sand in Chicago. Okay, looking at the Brocher compaction, if you take a look at A and B here, they are well-graded particle size distributions, and their Brocher densities are very high. Now, if you notice that the dry density in grams per cubic centimeter are well above anything that a root could actually penetrate. D and C are poorly graded particle size with significant amounts of sand-sized particles. If you take a look at the moisture contents here in these red bars, it doesn't take an awful lot of moisture for those finer textured A and B soils to meet their optimum compaction, where moisture content for the sands are actually a lot higher. So therefore, reaching optimum density, we are allowed a little more wiggle room during installation process. Now, the other thing we can also deal with too here is we'd like to see a system of pervious paving in between the trees to allow for flow into them to offset the droughtiness. The other thing it also does is if there's any kind of detritus on the sidewalk, you know, fine organics or whatever like that, that will also get into the system too and feed the roots. But it also has contaminants that would possibly cause problems for those as well. Hopefully we can get a flushing from that system to make sure it doesn't overflow and override the trees to the point where we get failure. Okay, this will give you an idea of what it looks like during installation. Soon as I see an installation of the silver cells, I will have photos of that. But right now, the Shoemaker Green at University of Pennsylvania, this is the sand-based soils going in. This is the gravel being applied on top of the geotextile before, this is after the compaction is being done. This is the trees that they are put in, and the geotextile is pulled back away from those trees. They put gravel back in, and then finally, this is the pervious paving going in. And finally, the last thing I want to just touch base on, if we ignore the soils that we're putting down and the proper use of soils and the proper locations of our using our tools in our toolbox, we could have some failure issues. So don't take the idea that we can save 700 lire by not taking soil tests. Okay, that's everything that I have right now. Okay.
I'm Chris Siciliano. I am with Stancils, and I'm going to bring up our next presentation. A lot of times I have a lot of questions. We work with a lot of landscape architects how to specify material and to just how to get it right. There's a lot of questions, a lot of concerns, commonalities, failures, successes. So this is sort of just from a blender's perspective, kind of what we go through to kind of maybe lift up sort of any mystery of what happens behind the scenes. Stancils were founded in 1934. We're in Perryville, Maryland. So we're actually just right on the Maryland-Delaware line, just about 150 miles from the city, serving the mid-Atlantic market. We are heavily invested in the technologically advanced blending and proportioning systems. The proportioning really is a key, I think, that really often gets overlooked. And with this technology, we can specialize in custom blends. Just a quick look at sort of a couple of the materials that we go over. I want to go a little more detail. Sky Garden is our green roof material. I'm not going to really get too much into this because I've sort of chosen this as to be the topic of a lot of what we're specifying later on. And so we'll get into a little more of that. I couldn't show anything from New York. I couldn't have any favorites, but we are up in New York probably about once or twice a week during the season. Materials that we are selling beyond that, we have, if you guys are familiar with organic lock or stabilizer, these are binded aggregate materials. They both have the same basis to it. There's a binder that gets mixed with stone dust, and then we saturate that, it swells, and then when it gets put into place, it will be compacted, and that gel will have coated all of the aggregates, tightened it up, and then when it dries, you basically get this loose material on top. Basically, Tim had a great aspect that well graded, that 45% slope. That's exactly what we're looking for. We want compaction on this. And so the other thing that I really liked about this one is you can see, I just really always like this picture. It's a great park. It gets hundreds of thousands of people a year walking by this, but you can also see that slope to the upper right. So if you are looking to do any of these products, it would be good to have a conversation with your local blenders. And we're going to maybe make suggestions on ways to help divert water away so that you can have a successful project without a lot of washout. I think you guys do have somebody in New Jersey doing the stabilizer organic lock. We're the closest, and the next is Reed Custom Soil up in Boston. So hopefully between us, you can find some colors that you guys like and within, less than 200 miles. Our custom blending, just to kind of give you an idea of what we were doing, this was a project that was out in Louisville, Kentucky. They had a washout, I believe, back in 2017. The river flooded and took out a huge amount of this. Really, this is just a public space. It's an art scene. They did a wonderful job. If you haven't been there, it's worth stomping out, turning the areas around the highway and under the highway into basically parks, festivals, things like that. And so we had this material gets driven on quite often. We had to do color match. There were certainly a lot of blenders that were a lot closer, but we had the experience. And I think at the end of the day, everybody was really happy with what ended up. Here we are in DC, the National Mall. These are the walking paths on the mall. This was a 5-component blend. This even kind of pushed our limits a bit. Be able to keep this job on target and moving, but to keep it.
Says she wants to know to come. Which one would you rather her come to?
So sorry. So this is a material where you really want to have a very good qualified blender because you've got to have something on this scale where it's going to be, I have to match up the soils from day 1 to day 30 as it's wrapping around. So when these guys come back in 3 weeks later and you're butting up, it's got to be, a spot on match. We also did the soils as well on the mall. The first half, this half that you're looking at was 2012. The back half was 2016. And this was just a great project to just throw in. Facescape is an artist's rendition. It's what America looks like. It's like kind of the average. Take about, I think it was like 30 photographs and overlap them. And we were really just brought in. They were kind of at a standstill with, and we were brought in as a consultant on it just to help. And it's 6 acres. And so anyway, the picture on the left was under construction. And if you actually look under the lip, there's 2 people there with fluorescent vests on. And so it's really just to give you a size. This picture was taken from the Washington Monument, and the other one obviously is from the satellite. So we do equestrian footing as well. And this was an interesting job because this is a park that is the Fair Hill Training Center, is a well-known training center. Several of the cup winners are there. They wanted to follow basically what was done, a practice over in Europe of having an equestrian festival with multiple disciplines. And so you'll see in the middle, the gray areas are for dressage. You're going to get a sand track, you're going to get a turf track, and then also in addition, off to the left in the upper corner was a cross country that actually merges onto these tracks. And our role was to help them define what this center, it's C33 at the bottom, drainage was key on this. And so it was organics that were being brought in. So in essence, it was fairly simple, but really asking all the right questions. And I think what we were doing is talking to the sod grower and then kind of the designer out in Michigan to find out what was that right organics, what was the right coarseness level, and then let's bring it in on budget. And so we were able to find a suitable material that was going to meet the needs. Just as Tim was saying about sand shortages, if you want to try to put something like this in, you can imagine there's not that much sand sitting around just waiting to go. Take some planning. This is really, I think what we're talking about in the project is this presentation is raising our expectations in the profile of the industry. We take a lot of pride in the work we're doing, and I'm going to kind of go through what we're doing, right or wrong, just to kind of give you a heads up on the questions we're asking. I used to have a pro presentation that was about half an hour long. You're going to get about the 3-minute version of it, where I would work with landscape architects, and constantly it was the same frustration of same specification, different results. And it's not even from different suppliers. Sometimes it was the same supplier, and it wouldn't only change job to job, it could change truckload to truckload. And so what makes for a consistent quality blend, we'll go through is the knowledge, your blending capabilities, your proportioning methods. This is something that I think all too often gets left out of it, and the source material. So this is a loader, as we all know. The most common blending method is pad blending. So pad blending is either on an asphalt or concrete, and typically what they do is they have a formula which tells this driver to pick 2 scoops of that, half a scoop of that, another scoop of that, put it into a pile, scoop it, lift it, drop it, and back drag it out and do it. Now I want to be clear, this can work. It's a reasonable way of doing things. I don't expect people to have invested the way we did, and it can work, but you can also see this as be an option, an opportunity for human error. If a project is being rushed, if it's a moisture content, yes, there are scales on these things, but yes, there's also moisture content differences. And so things are going to weigh different weights on different days. And so this just could be a potential issue. What you're going to get from that is inaccurate proportioning. It's inconsistent mixing, especially if it's wet. It can be prone to contamination, though that doesn't seem to be as big an issue, but in fact, would just be something to be aware of. Inconsistent results. If you're testing this, if it's not being mixed or proportioned correctly, you could get inconsistent results from it, and time consuming. Okay, this is our blending plan. So this is kind of the opposite end of the spectrum. I'm going to kind of walk you through. First, we're going to focus on the proportioning system. That's all this thing does is proportion. It's like we're mixing paint. So on the left, you're going to see we've got the loader there, and that's most of the materials. It's going to be aggregates, it's going to be compost, it's going to be sand. Any of those things are going to go into this blending plant. The super sack material also goes in, and that's going to be anything like it could be materials, organics being shipped from farther away, like rice hulls, something like that. It could be vermiculite, perlite, something that's really light and could blow away. And it's usually to protect from the weather. And then anything else that they let me put in the bins there. So each one of these bins has a monitoring system underneath that controls the amount of material that drops onto the collection belt. So that picture on the right, if I can leave you with anything in the presentation, it's that picture. It's pretty common when we're making our materials for it to look like this. So what you see there is a constant pattern. And so I can make 2,000 yards of material a day that is perfectly specced material because of the methods that we use to blend this. If you were to stop that at any point in time, clear off the belt, test it, you know, that section of it, you're going to find that it's going to be consistent. Now it's up to us to make sure it's accurate, but it's going to be consistent throughout. On the left, the picture is just showing you go to the blending plant, and then on the right, it comes out. And hopefully you can see this. So here we are loading it. Happened to be a rainy day, but that's the day that we got the guy with the drone. Material, consistent pattern all the way up, down through the blending plant, shoots off to the right there. And as you look, every bit of it is consistent coming out. Okay. So some of the results of like poorly designed soil. Short term is mostly focused on, a lot of this is based on green roof materials. It's 90% of what we send up to New York. So the short term, sedum, mostly are going to be affected by this. Other plants are probably going to be happier with it, higher organics and a higher moisture content, but a higher organic mix is going to have a greater level of compaction. Drives up the cost because you need to bring in more material. It would be a cubic yard, but then if it's going to compact 20%, you need to order extra. You get stunted growth, especially with sedum. They don't want their feet wet, and it can delay the root establishment. And so that just leads to higher maintenance costs. You're getting more weed seed establishing. But that's what if it's sedum. Now here we're looking at this, the long term is a loss of volume. And this is really our concern. Once you lose volume, you do get some root exposure. That's not the end of the world, but it's the diminished permeability. That's really when your performance is really going to start to suffer. So all organics are made up of organic and mineral. And when that organic breaks down, the organic is taken up, but the mineral portion stays behind in the forms of sand, silts, and clays and clogs up void spaces. And so where you had a very well draining system 2 years ago, you no longer do. And once the fines are in, you can't remove the fines. So you it's one of those things where you get what you pay for. So I've renamed this one, I don't know how many times. It's not really cause for concerns. It's just things to consider as you're going through and just some things really to pay attention to. Test data, and I am pretty serious about this one. We test every 6 months. Now, that said, we're probably at 6 months right now. We don't have anything back, so we're at 7 months, but certainly nothing more than like a year. People should be monitoring at least that long. I've seen all sorts of stuff be submitted where it's been a lot less or a lot longer than that. Now, we do so much custom blending that I have dozens of formulas. I can't possibly send them every year, but if there was something you were interested in, I could bring something up and we could retest. Ignore the marketing and focus on the testing. There are some great designs, there's great concepts. I don't know that I agree with all of the end results of them. It's just kind of packaging. Focus on the test results. If there's systems that they're telling you to use and they're telling you all the components, at the same time focus and say, well, should I really have that much organic in a mix? Or should my drain rate really be there? And those are things to consider. Beneficial reuse and sustainable materials. We definitely use, we have beneficial reuse materials, sustainable materials, we do, if they work. Priority one on any job is, does the material work? Does it fit with the mix? And just because, and we all kind of like those terms, it's always exciting to say that, oh, there's a beneficial reused material in there at 20, 30, 40%. But there's a lot on the market that probably shouldn't be going into a green roof or other mixes. Regional blenders, a lot of us blend more than one material for more than one, like we make more than one green roof mix. You know, we blend for other, we're all regional blenders for other people. And so if you find a regional blender and you like their materials, if they are the regional blender for another material, you're probably going to like that as well, because as we stated earlier, they have the knowledge, they have the proportioning system, they have the blending capabilities, and they have the source supplies that have worked for you in the past. And in the same light, if there's one that you don't particularly like, where the material is coming from, you should probably expect the same thing, because it's the practices that are involved with the blend are just as important as the design of the blend. The next sort of thing of concern is sort of these compaction factors. They're giving really large numbers for compaction factors. I guess we've always been at like 5 to 8%. I've tried to get it lower and we really can't. But the 15 to 22% has always seemed a little large. And I don't really two things I kind of came up with is either too many organics, and it's just compacting when it gets on site, because organics will compact, aggregates won't. And it'll settle, but they're not going to really compact too much. Or it's just simply marketing. I think there's been some very creative marketing out there. And, you know, if they're going to be, maybe it's not quite a yard and you're factoring in for it, but either way. Organic percentage would be another one, you know, kind of looking at a lot of what even Tim had brought up, like between 3 and 10% for your top layers of organics. That sounds fine, but that also seems really high for sedum. They don't need that. So when organic is sort of used as a filler in those situations, it's the cheapest material in there, and it's how you can bring costs down, but I wouldn't expect longevity in the mix. As you're looking at your sources, you know, are you generally happy with who you have? Are you happy with your current mix design? So are you seeing a loss of volume? If you're not seeing a loss of volume, that's excellent. If it's predictable and it's consistent, again, that's excellent. So if you can kind of say, yeah, there really hasn't been a loss, but it has been really consistent, you probably found a good source. Hopefully you're content with it. You can probably stay where you are. Are you using your design? Is it your mix? Is it a supplier's off-the-shelf mix that you're adopting? Or is it a system manufacturer's design? And if it is it under warranty? So those are all things to consider. If you're using a whole warranted system, you couldn't swap out the organics without their buy-in. So our design method kind of boils down to this. We do not write specifications that steer you to Stancils. We write them to raise the profile of the industry, and that's always been very important to us. There are specifications out there where people have asked, we really want to make sure your Sky Garden gets on this project. Well, you know, if it's an or equal and it's an equal product, there's not a lot we can do about it. We have some basic design principles we've developed over the years, been lots of trial and error, lots of testing, and we pretty much stick with those parameters in our designs. So as long as we're kind of sticking within that range on a design, we should be successful. Haven't had problems yet. Sorry, but the physical and chemical characteristics. When you're talking with your blender about changing things up, they really have to know their physical and chemical characteristics really well, because they're going to overlap and interplay. And, you know, unless you have a really good understanding of what the outcomes are, you can have results that you're probably not anticipating. Sorry. So if you were to, for example, if you wanted to make something lighter weight, you know, and you're going to pull out, you know, or if you wanted to remove some lightweight aggregate, they should be able to tell you like the 10 things that are going to happen from that. Like once the aggregate's reduced, aggregates tend to have a high pH. And so your pH should drop. Well, you also are going to have proportions of material. You're going to want to fill it with something, because if you put more organics in there, then your organic compounds are going to rise. There's just a lot of ins and outs that you really want to be able to focus on. The way we do it, we envision, you know, when we're designing like a cubic yard, that we're getting you about a cubic yard of aggregate. Cubic yard of aggregate is not going to compact. If you have a cubic yard of aggregate now and you're running water through it, getting your drainage out of it, and then you run it 30 years from now, it should generally be the same. You know, you're not getting a lot of breakdown with, you know, it's just the void spaces remaining. Our organics are generally filling in void spaces. We're using very few organics. When you pick up our material, it is the vast majority of it is aggregate. So that's generally kind of like the sign of a good material. We have happier plants, leads to quicker establishment, lower cost of maintenance, you're getting less weeds in there, and long-term success. So when you're specifying, a couple things to consider. You may have a great compost source, and if you are, just check to see, ask what it is and see what their latest testing is. Make sure the pH is kind of where you're looking for it to be. You could request a minimum amount of organics, or I'm sorry, of aggregates in there. The source of aggregates, I guess, while they're not all equal, they all have advantages and disadvantages. I don't know that I would specify one or the other. You've got two good sources up in New York. You should be fine. Warrantying against a loss or compaction, it's kind of something we had talked about. Guaranteeing that if there was a loss, they would make up for it. I think the accepting the or equal, that tends to be a big concern a lot of times. I hope that you guys get to work on jobs where you actually do get to enforce the or equal. You want to be looking at higher pHs could be a thing. You know, if it's a lower drainage rate, it's probably only going to get slower as the materials start decomposing, weights. So although I just spent a whole time going over sort of the blending systems, I don't recommend specifying specific or eliminating certain blending systems. You know, I think what makes this industry great is that we sort of went through the innovative period and we're more into almost like the economic period right now of how to make it cheaper. And I'd like to get back more to the innovative. And I think that, you know, you can get some people with some great, wonderful ideas, and I'd really like them to be out there. So, and be able to, and I don't expect them to have the equipment and the materials that we have to be able to do it. So in order to push it forth, I think it's good just to make sure that they're doing a quality job at that. So when you're talking to your, you should be talking to your blenders about, you know, talk about what your project goals are. If you are specifying this under grant funding or reimbursements or any of those programs, we have very, very different requirements and very different testings, be it DC, Philadelphia, or New York. And so we have to stay on top of all of that. So make them aware. Weight restrictions are pretty easy to modify. pHs, organic contents. If wind uplift is a concern, moisture retention is a concern, you want to make sure that they know that. And we are aggregate peoples, you know, we blend and design. We don't, at least I'm not very well versed in plants, so I don't always know what your plant needs. And so I work with you on that, and you would kind of share with me what those needs might be. Great, thank you.
Thank you, Chris. If you could stop your screen share. All right. Last, we'll hear from Laura Solano. Laura, feel free to start whenever you're ready.
Hi, everybody. It's been so interesting to listen to Chris and Tim talk about their experiences. And as always, I learned a few things that I'm going to tuck in my handbook. So I'm kind of bringing up the end of the conversation back to landscape architects and what has to happen in order for you to have successful soils on the project. So first of all, I'd like to say I'm not here to give you answers. I have no answers because the questions always change with whatever project you're doing. I do have a lot of experience. I've been at MVBA for about 30 years, and then 10 years before that, I practiced with other firms. My career with soil really began at MVBA. And I've seen everything, and yet I haven't seen anything. I've been through a lot of good times and a lot of tough times in dealing with soil, but it's always worth it. The struggle is always worth it because the results are just so phenomenal. So why is horticultural soil so hard to get right? These aren't all the reasons, but I think that they're big reasons. When you make a landscape, you inherently threaten the horticultural soil. The resource is really at risk. And I've got to point the finger right back at ourselves. Too many landscape architects just don't know enough about soils, so they can't speak about it intelligently with the client or the contractor or other engineers on the project. The soil market is often unprepared to meet the demands of, these more prescribed materials. But as you begin to become educated and get more and more experience, it's really your responsibility to collaborate with them, to learn from them, to teach them, and to lead your own project so that you end up with what you'd like. And the other thing that I think influences it is that, there's lots of soil information out there, but most of it that we use for built landscapes comes from agricultural soil science. And that while that's wildly important and really the foundation, it's not enough if you're talking about built landscapes. So what I'm hoping to do in this session is to really shift the thinking for landscape architects as to how they can speak with clients and how they themselves can also think about how to regard soil in their projects. So the truth is, anytime that you move soil, when you move horticultural soil, and by the way, that's what I call the soil that we use on our projects, horticultural soil. But when it's disturbed, it's changed, right? And from that moment of disruption, you need to manage it so that it can perform. Because really what you're after in the long run is for performance from soil that can, because it's hooked into so many other things. Making a landscape is really highly complex and also wildly risky. I mean, think about it. We tear apart the earth and we bring new elements in, we bring new soil in, and we are literally making a mess. And so it's our job to manage that mess and to make sure that every step of the way you are taking care of the right things. And soil is really the foundation, literally and figuratively, for all landscapes. So, and yet making landscapes is a really tough ride for horticultural soil. And I'm going to pause here for a moment and bring up a video for you to see. So I'm going to share my screen in just 1 second. Okay, this might even work. So this is a video from the George W. Bush Presidential Center, which my firm worked on. And The video was created from the cameras that were used on site during construction. So Manhattan Construction basically put this together at the end to kind of show the progress. But I think that while it's meant to show the whole project, and of course does, I think that it underlines just exactly what's happening with soil and why it's so important to take care of it. So let me warn you, there's some really corny music in here. I'm not responsible for that, but there are a lot of things in this video that I am responsible for. So as until I saw that, of course, I've always known that it's a lot of work and a lot of effort. But when you see, several years of construction squished into 2 minutes, it's really just startling how much work has to go into building landscapes and how raw they are. And I always cringe a little at the end of that video because while I think that the landscape is gorgeous, I know that it's kind of the way that new parents look at their newborn child as being kind of perfect when they're a little squished and not particularly attractive. So things get better on projects. So just take a few slides to talk about how did MVBA get here? How did we start using soil? Well, it was a modest and humble beginning. It started at a project called 50 Avenue Montaigne, which was a rooftop garden in Paris. It sounds snazzy, but it was just such a tiny little project. And because it was a rooftop, we needed to get some expertise on how to do that work and how to make sure that the plants survived. And so I was lucky. I got to be schooled at the knee of Phil Craul, who taught me so much about soil science. He and Tim, of course, have taught me a ton over the years. And so that's sort of how our relationship began. And I asked a million dumb questions across time, and still do. And people still continue to answer them. So in each of these slides, I've sort of given you a sense of what was there before we started building. And it's one of the main things that you need to look at when you start a project. what was there before you and how is it going to affect what you need to do on the project. And soil is one of those first things because it's often in scarce quantities. So we've gone through just quite a number of projects, looking at different uses, athletic fields, parks, planting beds, floodplains, urban fill, interior green walls, and a project down in the right-hand corner is the Portlands, which I'll show you a little bit more about later. So now assessing the horticultural needs and starting to figure out the costs and also look at constructability because of access and material available and sequencing, et cetera, starts to become a really deep conversation right from the beginning. Of course, we had lots of help along the way. I mentioned Phil and Tim, and there's Tim in his hole. That's often how you find Tim on sites. But there's a score of other people who have taught me and many people in my firm about how to deal with soil. And soil scientists don't agree with each other a lot. They do, there's overlaps, but I'm kind of, always balancing these relationships between everybody. And they're not just soil scientists in here, but there's also people who are really good with soil biology and using native soil, and they're just an encyclopedia. And everyone always says, well, I can't hire a soil scientist on my team. I don't have enough money. The client won't let me. But the truth is you can save yourself and the project so much misery, and also make sure that things are moving the way that they should be if you hire a soil scientist. Now, Tim, I want you to close your ears, because the truth is that soil scientists, in the scope of all of the consultants that we work with, are not that expensive. And so if nothing else, you might think about hiring them to do some consulting with you on a limited basis to help you kind of analyze things and get going. They're there to make sure that your design can perform and function at the end of the day. And they do it for a very specific site, for your needs, right? For your site, for your future conditions, for the existing conditions. So I really contribute a lot of our success on those projects I showed to having a partnership with a soil scientist. So why should we advocate for soil, and how do we do that? Well, and this series of slides is not necessarily things to take to your client to talk about, but again, it's the start of that shift in thinking about landscape architects' relationship to soil and their projects. First of all, we all need to remind ourselves that we don't make nature, right? Not at all. As I've shown you, we've actually disturbed nature quite a bit. But we do set the circumstances so that nature can take hold. And soil is at the base of that. You love plants, you better love soil, because there is a very deep connection there. Another is that increasingly, landscape architects work on sites that have been industrialized, urbanized, abused, abandoned, contaminated, or previously developed. And you need to bring that to your client's attention, right? You are not walking onto a site that already has a soil resource. You may find a little bit of that, as we did at the Bush Library, and we collected what we could. But we put that material aside and really had to import most of our soil. So you need to help your clients kind of look at the project look at their projects in a different way. You need to, understand what their ambitions are as they're doing the project. How are they motivated? And of course, they have much different concerns than you. They're interested in a project that goes well, on budget, on time, and, will serve what they intended to do. Because building is not easy, right? The decision to build, period, no matter what side of the table you're on, it's a big move. Hort soils are also the singular determinant, certainly in all of our projects, for sustained plant health. And healthy landscapes are easier and cheaper to maintain. This is a picture of Teardrop Park a few years after it was built. There were, of course, horticultural soils here. I think there were 9 different mixes, and I'll talk more about that later on. But you can see in 2020 just how much in 14 years, which if you're young seems like a long time, but if you have actually been at this profession for a while, you realize it goes by. And I also want to point out something else about this. The fact that there was a pairing between the trees and the soil is actually what makes the design work later on. So it was never our intention at Teardrop to have the ice wall be this, kind of brutish, very forceful presence, which it was early on in the site, but rather for it to be something that you discover, that you see from afar, and you're kind of curious about it. So if the plants hadn't grown, we would have lost that really basic idea of Teardrop, which was one of discovery and movement through there. There's only one place in the entire project that you can see the whole project, and everywhere else you're kind of enmeshed in nature. The other is that your clients have a pretty high wish list of multiple uses and experiences that they're looking for, right? They're carrying that in their heads too. But you have to remind them that soil has to be calibrated to be durable for those varied uses. So I think Tim mentioned earlier that, the soil that you would use for a lawn is much different than a soil you would use for, say, plant beds. And Chris showed materials for paths, right? And those require a much different composition, of soil related materials. So as you are developing this with the client, it's important to start to talk about soil. It's if you start the conversation at this stage, then they kind of start to understand that decisions that are made really affect more than just the hardscape. They also affect all the parts of the landscape that all of us are drawn to. When you combine a tree with healthy soil, you really get this great restorative system. And not only does it take care of sustainability, but it also helps combat climate change. And the numbers are kind of astonishing if you look at it. I won't go through them, but you can reduce runoff, you can collect CO2, over a year, can reduce the urban heat island. So this is a really hard working pairing if you do it right. Likewise, if you are interested, as we all are, in successful stormwater management, it means that you have to manage the soil, because in the overland stormwater systems that are being requested more and more, and that of course just make much better environmental sense, you have to have soil that kind of supports that journey of the water. So you're looking for soil in the swales that are shown here in that light blue, about for water holding capacity, cleansing, and then of course, plant establishment. You have to match the plants with the soil and the soil with the plants. It sounds so obvious, but people miss it and clients miss it. And then strange things show up on your projects, right? A request, and this was one that was very late in Teardrop, which was to use gray water from the buildings. Teardrop was supposed to be built before any of the buildings went up, and it actually was built after all the buildings were up, primarily due to 9/11. But so you have a client who wants to use gray water, and that's just such a great ambition, right? And of course you want to accommodate it. And they want to use the gray water to irrigate the park. Well, the problem is that gray water is full of salts due to our diets. It's actually kind of astonishing. Google it and you'll see that I don't even know how we're all alive. So what do? You have to explain to the client, if you want to go forward with this, we have to take care of things, right? So there is a small desalinization system in Teardrop. And in fact, many people don't realize that the Teardrop wall is actually the facade for this utility vault where everything is run from. And the desalinization plant is in there as well. It added about $30,000 to the project at the last minute. And lots of calculations were done, what was the recovery time? What was the message that people and clients were trying to put out? So in the end, we decided to do it. So we've gone through a lot of projects. And what have we learned? Hort soil is expensive, and that is probably one of the greatest deterrents for clients. They're concerned about it. I will tell you that there's also lots of talking between developers and clients who have a bad experience with horticultural soil on another project, and you basically are paying for people's sins. So, we'll get with a contractor and, he says, oh, I had a horrible experience with these manufactured soils in another project. And, the client has heard rumors and it turned into a mess. And well, it goes that way if you don't know what you're doing with soil and exactly what the plant system and ecologies that you are installing. If they're not matched properly, you're going to get in trouble. But if you end up having to use stock soil, and Chris, your mixes, I would take those in a day. But you should, at least on the East Coast, you should aim for loamy sand and consistency, amendments, verification. So it's not that you can't use naturally occurring soil. It's just that it is more intensive to use it, and you have to have many more checks and balances, and you yourself have to be much better educated. So one thing we've learned is that, I mentioned earlier that a lot of the science and knowledge about horticultural soil comes from agricultural soil. But if you really look at it, the ambitions of agricultural versus horticultural soils are quite different. So in agricultural soil, you're trying to grow food and fiber. And in a landscape, you are trying to get botanical experience. Agriculture has intensive growth. We look for slow growth, right? The type of materials that we use take time to become themselves. Agriculture has a short nutrient demand for that season, for that growing season. whereas we need a sustained nutrient supply. Agricultural soil, you plan for disturbance every single year, even if you're going to let fields lie fallow. The long-term plan for those soils is to be disturbed. We're looking to protect from disturbance. Agricultural soil, because of the depth of roots of crops, care about the O and A horizons. We care about the O, A, B, and C horizons because we need it for tree structure. We need it for the entire root mass. Agricultural soil is isolated from public use. Ours is engaged with public use. And ag soil has a contained natural systems, and we have joined natural systems. So they're different, right? And it's not that information from agriculture isn't relevant. It is, but there's another layer that you as a landscape architect have to think about when you are considering soil. So another thing that we've learned over time is that soil biology really matters, and that the plant-soil interface is really at a macro, micro, and molecular scale. And you have to maintain the rhizosphere, which is basically where all the business is done. It's a really thin layer of soil, as you see in the diagram on the lower right-hand side. It's where the business happens with soil. And you have to take care of that. That is the point of exchange and activity for nutrient cycling. The other thing that we've learned is that organic matter and clay are really critical to fertility management because their cation exchange capacity, their CEC, enables nutrient cycling. And here's more soil nerd humor. This is a fellow named Tom Wang. He's a professor at the City College of San Francisco, and there's his website if you want to look him up. But he basically has made cartoons of all of these natural processes, not just soil, but he has quite a series on soil, and they're really kind of fun to look at. The availability of quartz soil and compost as well, and for that matter, any kind of organics that you're adding to soil varies so much across North America. And yet we find ourselves working in projects that are far away from home base. So what do? Well, the first thing you need to do, and by the way, you need to do it really early because it affects cost and it affects the quality control later on. But you need to get on the phone, if not your feet, and investigate what the local resources and practices are in the location of your project. And there's, an important list of things to talk with soil suppliers in these various locations. Where do you get your soil from? How do you strip it? How do you stockpile it and then maintain those stockpiles? Do you make custom horticultural soil mix or mixes that you basically, kind of come up with? You make, sand, organics, topsoil, and that's your mix. It's the mix of the day. And also, particularly for compost, what's the processing and timing for turning windrows? I think we're kind of in a crisis in the soil world of getting quality organics. It's getting harder and harder to find material that is cooked and has reached a level that it can be blended with soil. I see it everywhere in every single city we go to. It flies out the door to places like Home Depot, who bag up this stuff and sell it to us on Saturday mornings. And we've had to actually convince the client to buy organics at the soil site and have them kind of pushed off to the side and maintained for us until we're ready for them. It's gotten to that point. And then, you know, how are they going to manage consistency and the quantities that you need and the schedule that you are trying to meet? One thing to tell your client is that, as we saw when I said, you know, we don't really make nature, when we're done with a project, that soil is still so raw and underdeveloped. You know, we've just put it through a blender, basically. So aftercare is really critical. And what this diagram shows is that there's, for the time, which is across the bottom, there's a lot of ups and downs before you reach a stasis point. And during that time, you are probably going to get a phone call or two from your client saying things like, I paid for all this soil. What's happening with the landscape? Why am I seeing nothing? So the story early on is, we're going to do this, we're going to do it together. But by the way, we both need to be patient because it's going to take time for these systems to kick in. But we have evidence, you know, from our projects that landscapes that use horticultural soil establish so much more quickly, and they endure minor issues and, you know, have sustained growth. And so this is the Peabody Essex Museum, and the way to orient yourself is with the building in the distance. And again, you know, this wasn't many years, it was 11 years to where you have a landscape that feels like it's been there for a while. And if you know, gave me a choice to walk in our design on the left-hand side or the right-hand side, I might go around the block on the one on the left-hand side. Again, that kind of scratchy rawness that landscapes have when they're young. We all experience construction delays. So one of the things that we've learned is, if horticultural soil was put down and is going to be left bare, the biology in the soil is getting threatened, because that biology, as I showed you before with the rhizosphere, really, you know, in order for it to kick in and stay kicked in, it needs that interface between roots and soil. So we have gotten into the business of using cover crops to control weeds and to sustain that root soil interface. It's so much cheaper to do this than to go in and remove weeds. You know, how do you do it? Do you turn them over? Do you use chemicals? No, I don't want to use chemicals. In Canada, you can't use Roundup. So a lot of things get, you know, taken out of your hands, and you have to find other ways to kind of combat those things in the beginning. So not every project can have prescribed horticultural soil, and we're facing that on a project in Toronto that's called the Portlands. So this is our site, basically. And the project is to renaturalize the Don River, which is right here. Because right now what happens is these areas around that mouth get horribly flooded. And so it's an engineering project. It's a project we're leading. And our bright idea was to put a river right through this industrial land and to create parks, leave parks behind as part of the flood protection. But guess what? We need 250,000 cubic meters, which is more than cubic yards, 10% more, that we need to find for this site. We did the homework that I said you should do earlier and could not find it. And so what we did is we convinced the client to pull out the horticultural soil and to bid that separately as a supply contract. And what we are doing is working with the owner of those fields that we're going to get soil from, naturally occurring soil, we're going to manage the soil over time. So basically, we are using naturally occurring soil for the project, which we've never done on this scale. So there's a lot of, my hands shake sometimes when I think about this. But we are being very careful working with a soil scientist, both one in Toronto and one from the States, and also hiring some really great biology people. And what we're doing is we are taking soil tests pretty regularly on site to figure out what we have. And also, we've already dug depths all over the place to see how much soil comes off. And we are getting both the A and the B horizons, which means we've got to scrape off all of the topsoil and area by area and grab that subsoil below it. And as Tim mentioned, right, it's already got the sort of local flavor of things. And the real problem here is going to be, how is it going to be handled? Because it has a higher silt and clay content. I'm happy for the clay because, you know, it will help with that nutrient cycling. I'm somewhat happy with the silt because it'll help hold water. But we got lucky. It doesn't have a lot of fine sands, which can clog things up. So wish me luck. We'll see you in 2024 at the opening, and you can see whether or not I'm smiling or otherwise. So I'm going to wrap up my talk about what do we really and truly need to know about horticultural soil and construction. Well, first of all, there are so many opportunities along the way to really screw up and ruin horticultural soil, getting the spec wrong, not doing your homework and finding a supply for it ahead of time, not warning your client about how much money it is, not being able to get the quantities that you need. But the rubber hits the road in construction. It's really the last stand. And you need to have a site presence because you've got a schedule going, and you want, your client wants things to move, and they couldn't care less that soil gets harmed when it's wet or frozen, but you do, because you know the consequences of doing that. Likewise, over compaction, just as you're moving things, as you're spreading things, as other contractors, you know, are want to take your beautiful field of soil and store their materials on it. So you really have to be so proactive. And one of the things that we do to help that is when we start working with the contractor, really during bidding, we talk a lot about what this soil is and what the expectations are. You go just shy of frightening somebody because you need them to be your partner. But you've got to get that message. It's almost like you hand the baton at every phase to somebody else with soil. And I'm sorry, you need to know the basics, which is, you know, we all look at these USDA sieve sizes and our eyes cross. What in the world does that mean? A number 10 sieve? But soil particle size affects behavior and performance. So if you look at this, the 270 and higher up to the 10 are all sand, and sand is inert. But sands are different, right? There's very fine gravel down to very fine sand, and fine sand and very fine sand behave much differently than the soil particles above it, the sand particles above it. It's also inert, of course, but it also slows water infiltration. You don't want too much, but some is a good idea. Likewise, silt, which is also inert, retains water, and clay does some really heavy work because it's chemically active and it enables nutrient uptake. So, I used to be really reluctant to have any kind of clay in our soil, but I've really changed my mind over time as I've seen results and figured out ways to improve the handling. Okay, we got to know how to look at tests and how to understand the technical aspects of this. Tim showed you this particle size distribution graph. And we've, this is something that is out in the universe and, in use many, many places, research labs, agriculture, etc. And we need to know how to work with these because we are visual people, and these graphs will help us to understand whether or not a soil is meeting specs. So we've kind of dolled up this graph so that we make it more apparent to people in the firm. And so the colored side is really, the range of particle sizes that we deal with in horticultural soil. And, those two numbers that you see in gradation in your specs, and when you're young, you have no idea what that means. And you're too embarrassed to ask. Well, it's really simple. It's just building where the blue lines are. It's building a soil envelope in which your soil needs to fall. And by the way, I think this is a Tim Craul soil because look how narrow that is. And this may have been, I can't remember what this is for, Tim, but I'm almost positive it's yours. So basically, when we do a job, when we start construction, we get out one of these graphs, we plot the soil envelope for every different type of soil, subsoil, loam, etc. And they lie in wait for when we get tests. And when you get tests back, right, you get something like this on the left-hand side, and it tells you the percent passing. And you can chart that here and see where the soil is within spec and where it's without. And on the right-hand side, you can see there's a failing test result because the proposed soil, kicks out quite a bit. I'll tell you, I've used these with contractors and owners about why can't you use that soil? Well, here, let me show you why. This is the envelope that we're trying to reach. And it's not that you can't go out of that envelope, but you got to stay somewhat in it or close to it. The other is to how to read and understand the basic test results. We do this thing where we ask for tests and we, put it in our specs, and we, we're really certain to make sure that these come as submittals. But it's sort of like, catching a wild animal and not knowing what to do with it. So you gotta pick up your game on this because there are some really critical things that you have to look at. And whether you're measuring soil biology or the chemical and physical requirements, you got to be able to look at these and analyze them, not to the level that soil scientists may, but you certainly to understand sort of what's good and what's bad about this soil. By the way, I should mention that one of the biggest benefits of working with soil scientists, besides the free education that they give you, is that they also give you the language. They want to teach you, and they give you the language of soil so that you can talk about it intelligently. And I'll make a parallel to, how you start to learn about stormwater and, the bell end of the pipe, or you're, working with lighting and there has to be a junction box, right? We gather that language really pretty regularly so that we can have conversations with engineers and others. It's the same with soil science. You really need to be able to talk and walk it. We require lab and field testing, and it's critical for compliance for sure, but it's even better for forensics. And by that, I mean, if something goes wrong, you can go back and look at tests, or you can look at grab samples that were taken and not tested, just to see what's going wrong, if you have something. But you know, the truth is that we don't get into that situation too often because we're constantly keeping up with what's going on site. But I will say, despite those at the Leaning Tower of Pisa not having spent their 700 lira wisely, soil testing is costly if you start to get into large volumes of soil. And it's time consuming from the respect of it takes time for the soil to come back. So what we've learned is, first of all, when we look at a soil, we look at gradation first. We don't even ask for the chemical. If the gradation is wildly off, then the other parts of the tests don't matter. So you're saving money on that. When you get the gradation right, then you can start to look at the chemistry of the soil as well. We used to test stupidly for soil biology really early, like at the site of soil supply. And what a waste, because soil biology changes, over time based upon the plants that it's interacting with, based on the time of year, et cetera. So what we do is we look at soil biology after the soil is installed and rests for a while so that it can get its wits about it. And then there's usually a pretty regular testing frequency in construction. But if things are going well and you have confidence that the soil supplier is doing their job and is as invested in it as you are, you can start to relax the frequency of those tests, so that all of those are kind of geared towards helping to save money and time. Because I always tell my staff, yeah, it's great to ask for all those submittals, and then we have to actually review all those submittals. So be careful what you ask for. And then the last point I want to make is that, yeah, you can do lab tests, you can go to the site, but you know what? Get down on your own hands and knees and look at soil. There's some really dumb ways to kind of analyze what in the world is going on with the soil. Is it too wet, too moist? You have a drainage problem? Or someone overwatering? Is the soil smelly? Probably means it's anaerobic and you're not going to recover from that. Or it's without odor, because bacteria actually gives us that great soil smell. So it means it's pretty lifeless and you got to build it up again or not. What's the texture of it? Is it, was it crushed while it was being put in? Is there a sheen or some other kind of chemical spill? The color changed over time, something's going on there. Is it really hard to dig in a bed? Even if you installed something, people are maintaining your projects, so they're going to be traipsing through your beds, right? So you may have to have them go in and kind of disturb the soil in order to allow air and water in. And has something been digging in the soil? Got to watch for that. And then, are you talking about a limited area or a site-wide area? So that you can really narrow down your analysis. So, you need to always learn. There's always stuff showing up. And, I peruse the web when I have a question about soil. And from the time that I began to now, it's just so much easier to get to educate yourself about this, to watch films. And, not everything you watch is right or good, but you do what you do with materials on site, which is you get verification. You just don't get an opinion from one person or one manufacturer. You kind of fish around. So, it's educating yourself, it's educating your client. Remember, your client doesn't really care about the technical things. What they care about is how that soil is going to help. I guess that's it. So let's have some discussion. Thanks, everyone.
Thank you so much, Laura. That was great. Chris and Tim, if you want to turn on your cameras and unmute, then we can answer a couple questions. Great. So we ran over a little bit. I'm not sure if you guys mind staying a little bit late for questions tonight.
I'm sorry, that was my blabbiness. I'm so sorry.
I couldn't stop you. It was also interesting with all of you tonight. So if you don't mind, but if you have a conflict, that's fine too. I would like to start by mentioning that Diane sent the information for the quiz and evaluation to the chat. I can ask her to repost that again in case you missed that. Both the evaluation and the quiz must be completed to get credit, and you need a score of 75% to get credit on the quiz. And with that, I'd like to start out with a question of mine, which is there a particular resource, I know there's a lot out there, including this presentation now, that you recommend to landscape architects to continue educating themselves on soils? Anyone can start.
Anybody in particular? Well, there's two books that my dad wrote, and then there's the book that my dad and I wrote, but hard to find that because it's sold out. So, but I'm working on edition number 2, so as we speak. So hopefully I can get that up to be printed, downloadable printed, so that it'll be more easily available and not paying a right arm and a leg to John Wiley and Son. So there's also other forms in landscape graphic standards. There's 2 chapters in there that my dad wrote, and I think there's 1 chapter in there that I wrote that basically kind of cover the general background of this to help you with that. I would also suggest that you would pick up Brady and Weil's Introduction to Soils, because that's typically the standard introductory soils handbook that most courses have. And a lot of the stuff that I pulled out that I spoke to today came from that. So that gives you the basis to actually start, and then getting into the urban soils, because the basic introduction to soils tells you the basic properties and whatnot, but the my dad's urban soils books are the ones that actually tell you the difference between an agricultural and forest soil and the stuff that we have to contend with. So there you go.
I'd also recommend that you visit extension service sites, because they're starting to put out some really interesting articles and to reference, right? They're there for, the homeowner and agriculture to kind of get assistance, provide assistance to them. And so it's really basic. And I learned a lot from those sites in the beginning when I knew nothing. And there are often links to other articles. And as you kind of roll into this, one thing starts to connect to another. and you start to see a name, you know, of a particular scientist or a project. But, you know, the most important thing is just get your feet wet.
No, there's a good point there, Laura, because a lot of those fact sheets that those extension services put out are basically 1 or 2 pagers.
Mhm.
And those 1 or 2 pagers have an awful lot of information. And then you don't have to, you know, riffle through a textbook. But with that, you also need a little bit of background knowledge to actively, you know, play with those some of those things as well.
Well, those great books will make, you know, much more sense if you have just a little base to start with.
Yeah.
That's great. Thank you. Chris, did you have any to share?
No.
Okay, great.
Nothing to add.
Well, I think we pretty much covered that. One question that we have in the chat is, what are best practices for using native or parent soils in a heavily urban environment?
The best thing would be to keep it fluffy. If you use a natural finer textured soil, the limitations on the productivity of that soil would be basically your program. So if you have a high use of programming on that particular site, then a natural finer textured soil will not, you know, do well for you. You'll be spending an awful lot of time fixing stuff over the lifespan of the project instead of going with something a little more robust. However, if you do not have a large level of programming and it's a recluse garden, let's say, in some kind of sanctuary where you basically have a bunch of monks walking around, then that level of the natural soil can handle it. Like for example, what they do in England is they have different levels of use based on how high the fence is around the park that they're using. So for a high fenced park, you could probably use a natural soil with very little, just ensure when you're constructing it, you don't compact it. But you know, anything that starts using the mid-level fence where it's basically picnicking, yeah, you may have some desire lines that you need fixing and along that stuff. But if you get down into the higher use stuff, then the level of remediation is going to increase over time. So it all bases on that cost of that programming that you're wishing to go with.
I'd
I
also,
hope that answers your question.
I'd also remind people that you don't have to take, you know, the first soil that comes along. You know, within the you know, native soil in an area, there are differences, right? You know, if you went to shop for a
Yep.
raincoat and you wanted a hood, you wouldn't walk out of the store with a raincoat that didn't have a hood, right? So it's the same with soil, right? There are choices. So you can say, this isn't quite it. You're close, or you're not close at all. Let's keep looking.
Great, thank you. Following up on that, if we get on a project later, as we often do as landscape architects, how can we, let me just read the question directly. If we get on a project after much of the subgrade planning and design has been completed, how can we best address soil issues?
Is that related to most of the subgrade work is done and we're icing the site, I guess, if you will?
I I think that's what it means. So most of the subgrade work is completed and we're brought in for the final grading and planting designs.
Well, Chris and Tim can tell you more, but you do need compatibility between the soil you're putting on top and the subsoil. And you certainly need to scarify them to get them to kind of grip each other. And, you know, you may need things decompacted. And, you know, you got to tell your client, okay, I've come on late, but that's okay. But there are a few steps we need to take in order to make things go well.
Great, thank you. Okay. When you work nationally, how do you develop the knowledge of appropriate soil types and network in a network of soil suppliers?
Chris, you have people that come to you from out of state. How does that work for you?
We do. We've actually had to ship, we're shipping to Miami next week from Maryland, which is kind of ridiculous. But sometimes when you're the only guy that can do it, I would hope that there's, I mean, the other thing is I can tell you there's some resources regionally of some really good blenders who are out there who could, you know, I think a lot of it, look to see who's a green roof blender. I would say like any Googling you would do is find a green roof blender or bioretention soil blender. And what that simply tells you is that those are blenders in the area who have capabilities. The reality is the natural soil or the natural materials that they have aren't going to necessarily meet your needs. So I would look at an area for bioretentions, green roofs, and maybe some other types of specific like CEU soil blenders. Find out who a CEU soil blender is in an area. They're going to have blending capabilities. It's going to be the knowledge and the equipment and the materials.
You also have
When I was first starting out, oh, sorry.
Go ahead, Tim.
When I was first starting out, the first thing I would check is call up a greenskeeper of a local golf course. Because typically most of them run a USGA type sand mix, and they would have some kind of supplier somewhere around there for their top dressing, for their bunker sands, for stuff that they get supplied. And it's a good place to start. That's where I would go. And then I've done other places where I've actually gone in, found you know, aggregate suppliers that basically did sand and gravel, and educated them and actually got them to do soil mixing. And now they're, you know, soil mixing on an industrial scale and doing quite well. They're actually kind of glad that my dad and I came in and showed them how to do it.
You also, I think you also,
So there's that way you can do it.
You also could talk to landscape contractors. Who do you get your soil from? So you can start to get a toehold on who manufactures soil in that. Not that you'll use that, but so you start to get an understanding of what is out there in that region. And as Tim said, we found that people aren't used to using, you know, the kinds of soil or the care that's surrounding that. And you know, there are a lot of curious people in I don't mean odd, curious people in the soil world. Well, maybe odd, but you know, they're interested too. They're interested in hearing what you have to say. But you need to make the rounds. You can't, you know, call first, then decide where you're going to take a trip. You got to go see. You can tell a lot just by going to someone's supply site. Like if I walked into Chris's, oh my God, would be like Disneyland.
That's how we think of it.
I mean, the nice thing about New York State is there's some significant suppliers throughout the state that you can actually tap into that I know about. So you guys are actually a lot better off than you know, other places I'm dealing with right now. So where I got to go out in search of sand and gravel guys and say, hey, you know, you can do this if you really want to.
Great, thank you. Um, Another question is, most of the testing facilities test based on agricultural needs. Is there a different way of testing or something important to ask, which wouldn't really be looked at with those agricultural based tests?
I think I better answer this one because I deal with testing specifically. In horticultural testing versus agricultural testing, they're almost identical as far as what you need to do. The recommendations they give you should be ignored because the recommendations are based on those properties giving rise to productivity of agricultural commodities, not our horticultural soils. There's a few land grant universities that do a horticultural identification, but what you need to do is you need to educate yourself in what is a good soil, what kind of properties they need to be, and apply those properties to the testing you come in. Because typically I go through Penn State's testing for my work, and as well as another testing firm that does particle size distribution, but they also happen to be on retainer by the NFL for all their athletic fields. So that I know when I request from Penn State, I said, don't bother giving me the results, any indication, because they're typically just specific for that particular state. And they're also based on mostly agricultural research and not necessarily horticultural research. So basic testing is ASTM 1632 for your particle size distributions. I think it was ASTM 1647, I believe, which is the loss of ignition.
Tim, you're showing off.
I'm sorry, a little brain can is, but you.
No, I'm sorry. Continue. I'm sure people are writing this down.
I've had my second bourbon already. So. So you want to do loss on ignition. You'd like to do probably a Melnick-3 type study to get your cation exchange capacity, your salt content, your pH, and along with that, your basic macronutrients. I only suggest doing phosphorus and potassium because nitrogen is so flighty, it's very hard to pin down. The other thing I also want to mention too is that your potassium, phosphorus, cation exchange, your potassium, phosphorus, pH, and EC are all dynamic soil properties. They change over time. So I keep telling you, if the pH in one test comes in and you don't like it, don't be afraid to not reject it, because the thing you need to look at is pH is dynamic. We need to follow up with that and find out which direction the pH is going in. So if you get a freshly minted soil material and your pH is 7-8, don't reject it out of hand. Put it in place, find out what happens after a couple rainfall events on it, test it again, and if the pH is not dropped, then you have to add some amendments to it to lower the pH. So that's typically what I suggest, because you're looking at a dynamic property and you want to look at trends, not necessarily individual points on the scheme of things. So I hope that clarifies.
That's great. One other question. So this is for Laura. There was just a couple questions about the term horticultural soil. Can you remind us one more time what you define as horticultural soil?
Well, I define it as soil that you need to grow ornamental plants for landscapes. And it can take many different forms. It's just an easy, for me, it's easy, right? Instead of loam or topsoil or, engineered soil, it just is easier because I think it's kind of a good umbrella term. It's not necessarily implying any soil characteristics.
Great, thank you so much. We'll end it with 2 more questions. I don't want to keep you too long. One question is, how do you avoid settling of soil in soil systems, like in soil cells? I think that's for Tim.
The way I deal with it is that I would put in a self-supporting type soil, something that has a poorly graded, or as soil science call well sorted, material that has a uniform packing model, so that when we place it and we tamp it in place, the overall subsidence is less than an inch for a 3-foot profile. If we use a finer textured soil on that, let's say is shredded and placed, the only way to handle that is to compact it so it doesn't it fits in all the spots and stuff. It doesn't settle. By doing that compaction, you have now eliminated the ability of roots to penetrate it. So I would use a coarser system, like I mentioned in my talk. For other areas where I guess Bartlett Tree did a study on these different systems, and they found that I think the soil cell system settled the most at, I think it was like a 1/2 inch. But then again, they did not apply vibratory compaction to those sites. The sand-based soils performed the worst. And in my discussions with the author of that study, found out that the sand-based system actually cemented itself. So that was an issue that probably made a good reason why that didn't do so well. So in that case, then that's what I would suggest to limit the subsidence.
Great, thank you so much. Last question. I was just curious, with soil suppliers, the materials that they use to create their soils, are they primarily from the region of the soil supplier? How far out do soil suppliers get raw material from in order to create their soils?
I'd say lightweight aggregate, we're having brought in from Alabama. We're looking at sources. There's only about 8 or 9 lightweight aggregate producers. To get our quality compost at the volumes that we need, we're probably getting that from about 1.5 hours, 2 hours away. There just isn't, as was alluded to by Laura had said, our source decided to sell everything to Home Depot and Lowe's. And so our source that we've used for decades dried up. And we have a certain quality that we need. There are people that are closer and we've given them a shot, but it just isn't, they're not managing their piles correctly. Certain stone dusts, I guess, could be up for like 1 hour, 2 hours away. But just to offer the variety of materials that we offer, we try to keep it within about probably 100, 200 mile radius if we can. Then just shipping just gets to be way too expensive on top of it. And what should be a reasonably inexpensive blend is just becomes astronomically higher.
Renee, I don't know if there are more questions, but I forgot a really important point that I'd like to make before we leave. So if there are other questions, let's go forward with those.
That was the last question that we're planning on doing tonight. So go ahead and you can end out the talk.
In sort of blabbing on about soil costs, I forgot to share some strategies. And that's such a hot topic that I think it's worth going back for a second and talking about. One of the things you need to do is make the case for soil for your project. not, like really understand your project inside and out and what it's going to face as a challenge during construction and its afterlife. And then you need to add Hort soil discussions from a really early stage. Like, it's matter of fact, because it is, you're going to need soil from somewhere. And I think the more that you just bring it up and not, not mention it until the soil comes in the submittal is doing yourself a disservice. And then it's also, we found really great to horse trade for soil, because we found that soil makes plants so healthy so much faster that we're happy to downsize trees and put it towards the cost of soil. It's really that worth it. And then the last is that you may not be able to get, horticultural soil for every single part of your project, but there are places you should advocate for. So a lawn that's going to get a lot of use, or plant beds that have that nobody will cut through, but they need a lot of organics in order to thrive. We also have adjusted pallets. Like if we were able to get soil in plant beds and in the lawn, let's say, another strip, we couldn't afford the soil. So what do? We take the local soil, but we adjust the plant palette so that it's matched with that local. It's much tougher trees. So like poplars, alders, they're just like so forgiving. So don't be pig-headed and think you can just plant what you want to plant. You have to calibrate it with the soil as well. When I worked with a fellow in the Greenway in Boston, and I was talking to him about organics, and I was getting all worked up about it, and he said, Laura, if you get your client to do 60% of what you want to do, you've made a lot of headway, and you at least have gotten the subject in front of your client, and they'll see results and they'll think twice the next time. So my parting words.
Great, thank you so much. And thank all three of you for speaking with us tonight, and everyone for attending. This was such a great talk, and we look forward to continuing with part 2 next week. So everyone have a great night.
Thank you.
Goodbye, everybody.
I'm just watching people kind of sign off.
Oh yeah.
Did we need to stay for anything?
No, you're free.
Nope. Thank you
Okay.
so much. Next week we can stay for the happy hour.
Perfect. Thanks,
Thank
everyone.
you. Renee,
Bye-bye.
you did a great job. Thank you so much.
Thank you. Have a
Have a
good
good night.